There's a powder on the shelf at your hardware store right now that costs less than a fast food meal. It has been there for years, and if you knew what it actually did to the temperature inside your home, you would have bought it the same day you moved in. Your roof is not protecting you from summer heat, it's generating it. Right now, on a hot day, that dark surface above your head is converting sunlight into thermal energy and pushing it straight down through your ceiling into every room you're trying to cool. Your AC is not winning that fight. It never was. And a professor at Purdue University proved in 2021 that a coating you can mix in a bucket beats your central air conditioning unit on every measurable metric without drawing a single watt of electricity. We're going to break down exactly why that's true, exactly why nobody told you, and exactly what to do about it before next summer arrives. Start with what your air conditioning unit actually does, because most people have this fundamentally wrong. The instinct is to picture it as a cold generator, a machine that manufactures cool air and fills your house with it. That's not the mechanism at all. Your AC is a heat extraction system. It finds heat that already exists inside your home, moves it through a refrigerant loop, and dumps it outside, and that's the entire job. It doesn't make cold, it relocates hot. And here's the problem baked into that design that the HVAC industry has very little interest in drawing your attention to. While your AC is working to pull heat out through one side of your house, your roof is continuously manufacturing new heat and injecting it through the top. A standard dark asphalt shingle roof soaks up somewhere between 85 and 95% of every bit of solar radiation that lands on it. All of that absorbed energy converts to heat, conducts down through the roof structure, and hits your attic. Attic temperatures on a summer afternoon in most parts of the country regularly climb past 140 degrees. That's not outside air temperature. That's a furnace you built above your living room. That heat radiates down through your ceiling continuously all day, every day. The sun is out. Your AC is not competing with the weather. It's competing with your own roof, running in a loop it structurally cannot win, spending the majority of its capacity just trying to keep pace with the heat being generated directly overhead. Every hour your AC runs on a hot day, most of what it's doing is cleaning up after your shingles. Now, here's where the physics gets interesting. What if you interrupted that process at the point where it starts, not inside the house, not at the ceiling, but at the surface where sunlight first makes contact? That's the entire logic behind the powder. And to understand why it works so completely, you need one concept: solar reflectance. Every surface has a value that describes how much incoming solar radiation it bounces back versus how much it absorbs. Dark asphalt shingles sit at around 5 to 10% reflectance. That means 90 to 95% of everything the sun sends down gets absorbed and converted to heat. Standard commercial white paint, the product used on most white flat rooftops you've seen, gets you to about 80% reflectance. That sounds dramatically better, and it is better. But even at 80%, a roof of average size is still soaking up the thermal equivalent of 2 to 3 continuous kilowatts on a sunny afternoon. That's still a meaningful heat load pouring into the structure below. Hydrated lime, calcium hydroxide, a material Minoan builders were using on their walls more than 3,500 years ago, reflects between 95 and 98% of incoming solar radiation. The math on that gap is not subtle. At 80% reflectance, you're still absorbing a significant fraction of the sun's energy. At 97% reflectance, you've nearly closed the door entirely. A study at Lawrence Berkeley National Laboratory in 1973 ran this experiment directly. A lime-treated rooftop side by side with a standard dark roof. The treated surface ran 40 degrees cooler. Interior temperatures in the lime-coated building dropped 8 full degrees. The structure required no mechanical cooling for the entire summer. That study is over 50 years old. In 2021, Professor Julien Rouen at Purdue University approached this problem from the other direction. He wasn't specifically researching lime. He was trying to establish the theoretical ceiling and the most reflective surface physics would allow a human to create. The formulation he developed uses barium sulfate particles sized and distributed to scatter light across the full solar spectrum simultaneously. The result reflects 98.1% of incoming sunlight. Guinness certified it as the most reflective surface ever produced. Peer review in ACS Applied Materials confirmed the performance data. But the number that landed hardest wasn't the reflectance figure, it was the cooling output calculation. Ruan determined that 1,000 square feet of rooftop coated with his formula generates 10 continuous kilowatts of cooling effect. A residential central AC unit produces somewhere between 3 and 5 kilowatts of cooling capacity. The passive coating outperforms the mechanical system by a factor of 2 to 3 and requires no power to do it. Now here's the connection that ties this back to your $7 bag of powder. The mechanism behind Ruan's laboratory formulation and the mechanism behind hydrated lime are the same physics operating at slightly different efficiencies. Both work through two processes. Your AC system doesn't use it all. The first is blocking shortwave solar energy before it converts to heat inside the structure. Pure reflectance, photons bounced back before they cause any thermal damage. The second is long-wave infrared emission, which is where things get genuinely strange. Surfaces with high emissivity don't just stop absorbing heat, they actively shed heat they've already stored by radiating it as infrared energy back out toward the sky. This is called radiative sky cooling, and it's the reason Ruan's test panels measured cooler than the surrounding air temperature even in the middle of a sunny afternoon. The surface wasn't just refusing new heat, it was offloading stored heat upward. Think about which direction your AC dumps heat versus which direction a reflective coating dumps it. Your AC pushes heat sideways into outdoor air. On a 95-degree summer day, that outdoor air is already nearly full. You're trying to empty a bucket by pouring it into another bucket that's almost at the brim. A lime-treated roof dumps heat straight up, radiating it into the sky, into the upper atmosphere, ultimately toward deep space, which sits at just a few degrees above absolute zero. The coldest possible heat sink in existence, and it's directly overhead every single day. So if this is real, if the numbers hold up, if a professor at a major research university proved it in a lab and got it peer-reviewed and certified by Guinness, why is every roof in your neighborhood still dark? That question has a financial answer. The global HVAC market is worth over $130 billion a year. The coatings and paint industry adds another $200 billion. Hydrated lime is a raw commodity. Calcium hydroxide cannot be patented. Nobody can trademark it or lock it behind a licensing model or build a subscription business around a material that costs a few dollars per bag and lasts for years once applied. A home that cuts its cooling load by 60 or 70% through a one-time $20 treatment is a home that doesn't need a new AC unit this decade. Homeowner associations in dozens of states have codified rules that prohibit highly reflective exterior surfaces and require earth tones, browns, tans, charcoals, exactly the palette that keeps solar absorption high and cooling demand predictable year after year. Those rules didn't emerge from a coordinated conspiracy. They emerged from an industry ecosystem where the financial incentives all point in the same direction, and nobody with money on the line had any reason to push back. Here's the trap that catches most people even after they learn about lime. They put it on the roof and figure the job is done. That addresses the largest and most direct heat source. But your home's walls are also absorbing solar radiation all day long. The south-facing surface takes sun across the entire arc of the day. East and west faces take direct exposure during morning and afternoon peak hours. All of that absorbed heat gets stored in the thermal mass of the structure, the concrete, brick, drywall, and releases slowly back inward through the evening and overnight. Ancient Mediterranean builders understood the whole system logic. The reason those whitewashed villages look the way they do isn't aesthetic tradition alone. It's because those builders learned through centuries of trial and error that treating every exterior surface was what produced the result. A single dark south wall acts as a slow-release thermal radiator pumping heat into your living space all afternoon. Flip that wall to 95% reflectance and you've essentially turned off that heat source completely. Apply that logic to every face of the building and the thermal mass of your home stops working against you. Total material cost for a full exterior treatment on an average house using hydrated lime is under $50. The application process is straightforward. Type S, Hydrated lime at any hardware store runs between $7 and $14 for a 50-pound bag. The active compound is calcium hydroxide. That's both your whitening agent and your reflective mechanism in the same material. Mix 1 part powder to 2 parts water until the result is fluid enough to roll on like paint but not so thin it runs. This is a lime wash, unchanged in its basic formulation from what builders across the Mediterranean have been using for 4,000 years. 2 coats applied with a thick nap roller over a clean, dry surface. First coat fully dry before the second goes on. Material cost for a 1,200 square foot roof lands between $14 and $28. A homeowner in Texas documented his results with before and after measurements. His attic peaked at 143 degrees before treatment. After 2 coats, the same space peaked at 97 degrees on a comparable afternoon. A 46-degree reduction from an afternoon's work and 2 bags of powder. Indoor temperatures dropped 10 degrees without the AC carrying full load. Electricity savings over that single summer came out to over $1,200. A new AC installation costs between $5,000 and $15,000 up front and then keeps billing you every month for the rest of the time you own the house. The Greeks worked this out when written language was still a new technology. A Purdue lab confirmed the exact physics in 2021. The powder that bridges those 2 data points has been sitting within driving distance of your house the entire time. The cooling industry's most expensive secret has always been one of the cheapest things on the shelf. You know where the shelf is. Now you know what to do when you get there.